Hello NSA student, this is Mr. Hinton with Math Department. One of the biggest topics in all of geometry and trigonometry is solving triangles, right triangles specifically, and this is a topic that is introduced to you in week 22, and it involves the trigonometric ratios. There's three primary ratios that we will cover in geometry. There's sine, cosine, and tangent, and one of this little acrostic that we use to kind of help you remember this is Soh Cah Toa. Soh Cah Toa, this deals with the sine function. This is the cosine function, and this is the tangent function. Okay. Now in this acrostic, the O is the opposite leg, and H is the hypotenuse. This is the adjacent leg, and again H is the hypotenuse. And for tangent, we compare the opposite and the adjacent. Now, each of these trig relationships is related to the angle. So let's just suppose we're dealing with this angle right here in the bottom corner of this. Let's say that is angle X, or that's X that we're working with. From the perspective of that angle, this leg over here is the opposite leg. This is the adjacent leg. And then, of course, the hypotenuse is always going to be opposite the 90-degree angle. So we have opposite, adjacent, and hypotenuse. Now, if I were to move the angle, let's erase these. If I were to remove this angle, move it to the other acute angle of the triangle, then the perspective changes. This becomes the opposite leg. This is the leg that's adjacent to or next to the angle, and the hypotenuse is always going to be unchanged because it's opposite the 90-degree angle. So that's how the relationships work, and the sine is the opposite over the hypotenuse. The cosine is the adjacent leg over the hypotenuse, and then the tangent is the opposite leg over the adjacent leg. All right, so let's clear this off. We have Soh Cah Toa that we're dealing with, and let's look at just some kind of generic examples of how this would work. So we need another right triangle, and let's say that this is angle A. Let me switch back to this. This is angle A. This is angle B, and this is angle C. And let's give some values here. Let's use our regular, familiar 3, 4, 5 right triangle. In this particular triangle, we may be asked to just find the sine of angle A. Okay. Now, using the trig ratio that the sine is the opposite side divided by the hypotenuse, or the opposite leg divided by the hypotenuse, the opposite leg to angle A is going to be 3, and then the hypotenuse, of course, in this particular triangle is 5. So that's how you would find the sine of angle A. It's just a ratio of those sides. Now let's talk about what the maybe the cosine of angle B would look like. The cosine of angle B is going to be equal to, because cosine is the adjacent side or the adjacent leg over the hypotenuse, the leg that is adjacent to angle B is 3, and the hypotenuse is still 5. So we could deal with any of these trig ratios just for a little more practice. Let's do the tangent of angle A. The tangent is the opposite leg over the adjacent leg. Well, the leg that is opposite angle A is 3, and the leg that is right next to angle A is 4. So opposite over adjacent there would be 3/4. Now, because these relationships are true in every right triangle, we can use these values or use these trig ratios to actually solve triangles that we're missing pieces of. Let's do one of those real quick, and then I want to work a common problem that comes up in our class related to this. Let's suppose that we have suppose we have a right triangle here. Let me draw this scenario. There's our right angle here in the corner. Give me a second. Okay. And we are given in this triangle that this is a 40-degree angle. That looks like about a 40-degree angle. And here is, the side is 5. And what we're looking for is this hypotenuse, which turns out to be the hypotenuse of the triangle. Now, the first thing you want to always do when you're given a right triangle problem is identify the pieces that you're given. What are we given here? We're given 40 degrees, which is good. We know that this angle is 40 degrees, and we know that this side is 5. And the side that we're looking for in this case is the hypotenuse of the triangle. So we have an angle. We have a leg that happens to be adjacent to the angle, and we're looking for the hypotenuse. So adjacent leg and hypotenuse tells me that I'm using the cosine function. And the cosine of this 40-degree angle is equal to 5, the adjacent leg, over the hypotenuse. Well, what this gives us, if we put this over 1, is a proportion, and then we can use cross multiplication to finish solving this. If you cross multiply, you get x times the cosine of 40 equals 5. And then at this point you could use your calculator to evaluate the cosine of 40, and then you would have a decimal, or you can just divide both sides by the cosine of 40 here. And what that's going to give us is that x equals 5 divided by the cosine of 40 degrees. Okay, so if we make sure that our calculator is in degree mode, if you're using a Texas Instruments calculator, it's going to default to radians. So you always want to make sure that your calculator is in degree mode if you're dealing with degrees, which we always will in geometry. So 5 divided by the cosine of 40 degrees is 6.53. So x is approximately 6.53 units. So we've solved this problem using a trig ratio. Now, the difficult problems here, the problems that tend to give students the most trouble when they're solving right triangles, is when you're actually looking for an angle instead of a side. So let's let what we're looking for in this problem is going to be this angle, and let's give this a length of 3, and this looks like about 5.5. Just making these up as we go here. Always identify what you are given and what you're looking for, and what's the relationship between those two things. So we're given two legs. This leg over the 3 is opposite the angle, and the 5.5 is adjacent to the angle. All right, so our x degrees angle, we have the opposite and the adjacent. Now again, using our Soh Cah Toa, we can see that the trig ratio or trig relationship that uses the opposite and the adjacent is the tangent function. Okay, so here's what I know about x. I know that the tangent of x is equal to 3 divided by 5.5. Now, anytime you're looking for an angle instead of a side, you're always going to have to use an inverse trig function. On your graphing calculator, excuse me, just above your tangent key, you'll see the tangent inverse key. So the way you solve this from here is to do the tangent inverse of 3 divided by 5.5. Now you could evaluate that and use it as a decimal, get the decimal approximation of 3 divided by 5.5. But it's easier, I think, to just use the inverse tangent of 3 divided by 5.5 in your calculator, and that will tell you that x is approximately 28.61 degrees, accurate to 2 decimal places. So if you're looking for a side, then you're always going to be just using the tangent or sine or cosine. If you're looking for an angle, you're always going to be using the inverse trig function to solve those problems. Thanks, and have a great day.